Hello everyone, this is Chinnaiah Kalpana here. In this video, we're going to see a problem from partial differential equations. So let's get good. Problem: form the partial differential equation by eliminating the arbitrary constants from z equal to x, a square x plus ay square plus b. We are given an equation or a relation z equal to a square x plus ay square plus b. And here we are asked to form a partial differential equation by eliminating the arbitrary constants a and b from the given equation, right? So we'll partially differentiate one with respect to x. We'll begin with partially differentiating one. Since we are partially differentiating with respect to x, so we'll treat y as constant. Just apply dou by dou x on both sides of 1. See here, we'll first begin with, we'll solve the problem in detailed way and later we'll go for the shortcut. We'll just decrease the number of steps, right? This gives us dou z by dou x equal to partial derivative of first term plus partial derivative of second term plus partial derivative of third term. Since dou z by dou x equal to p, we'll replace the first term, the LHS part, by p. You'll get p equal to a square into partial derivative of x with respect to x plus partial derivative of a constant with respect to x is 0 plus partial derivative of a constant with respect to x is 0, which gives us p equal to a square into partial derivative of x with respect to x is 1, right? Or yeah, we can write this as p equal to a square, or we can write this as square root of p equal to a, or a equal to square root of p. Consider as equation number 2. So you got a equal to square root of p by partially differentiating 1 with respect to x. Now partially differentiate 1 with respect to y. Apply dou by dou y on both sides of 1. Since we are partially differentiating with respect to y, so we'll treat x as constant here. This gives us dou z by dou y equal to dou by dou y of first term plus dou by dou y of second term plus dou by dou y of third term. Since dou z by dou y equal to q, so let's use this notation and replace the LHS part by q. You'll get q equal to partial derivative of a constant with respect to y is 0 plus a into partial derivative of y square with respect to y plus partial derivative of b, constant with respect to y is 0, which gives us q equal to a into partial derivative of y square with respect to y is 2y, which gives us, just bring this 2y to LHS, we'll get q by 2y equal to a, or we can write this as a equal to q by 2y. Consider it as equation number 3. Right. Now observe 1, 2 and 3. See, you're having a equal to square root of p and a equal to q by 2y. By replacing a using 2 or 3, a gets eliminated but b won't get eliminated, right? So it is not possible to find the partial differential equation by substituting any of these 2 or 3 in 1. So what we'll do is, we'll just use we'll just use 2 and 3. Since a equal to root 2 and a equal to q by 2y, so we can equate 2 and 3, right? From 2 and 3, root p equal to q by 2y, right? Squaring on both sides. Which gives us p equal to q square by 4y square, right? Now bring this 4y square to LHS, you'll get 4py square equal to q square. See, it does not involve any arbitrary constants, and this is the required partial differential equation. Which completes the problem. Now let's see the shortcut. Here you're having square root of p whole square, right? Which is written as p, since we know that square root of a can be written as a power 1 by 2, right? So we can write square root of p as p power 1 by 2 raised to the power 2. And we know that a power m whole power n equal to a power m into n. So you got a power m whole power n, we can write it as p power 1 by 2 into 2, which gives us p by cancelling 2, right? Fine. Now coming to the shortcut. Given z equal to a square x plus ay square plus b, right? We have considered as equation number 1. Now let's partially differentiate 1 with respect to x. Which gives us dou z by dou x equal to a square into partial derivative of x with respect to x is 1 plus partial derivative of a constant with respect to x is 0 plus partial derivative of a constant with respect to x is 0, right? Which gives us, since dou z by dou x equal to p, use the notation, we'll get p equal to a square, or we can write it as square root of p equal to a, or a equal to square root of p, considered as equation 2. Now partially differentiate 1 with respect to y. I get dou z by dou y equal to partial derivative of a constant with respect to y is 0 plus a into partial derivative of y square with respect to y is 2y plus partial derivative of a constant with respect to y is 0, which gives us, since we have a notation dou z by dou y equal to q, just replace it by q, you'll get q equal to a into 2y. Now bring this 2y to LHS, you'll get q by 2y equal to a, or a equal to q by 2y, considered as equation number 3. Now observe 1, 2 and 3. So you have a equal to root 2, a equal to root p and a equal to q by 2. You can substitute any of these a in 1, but by substituting any of these two, we can just eliminate a, but not this b, right? B remains the same. That is, arbitrary constants won't get eliminated by substituting 2 or 3 in 1, or 2 and 3 in 1, you can say. So what we'll do is, we'll just observe 2 and 3. From 2 and 3, we'll get square root of p equal to q by 2y. Now by squaring on both sides, you'll get p equal to q square by 4y square. Bring this 4y square to LHS, you'll get 4p y square equal to q square, which is a required partial differential equation, which completes the problem. Well, we have seen a problem from partial differential equation in this video. I hope you'll understand. We'll see you in the next video. Until then, bye.